Reaction rate. Reaction rate is the rate at which products form or reactants are used up. Chemical reactions occur on varying timescales. Some reactions occur rapidly and finish quickly. For example, acid-base neutralization. Other reactions occur very long periods of time. The example is oxidation of metals. So the reaction rate could be affected by the temperature, concentration, surface area, and the pressure of catalysts. So these four things could affect the reaction rate, whether it's going to go slow or fast if you want to increase the speed of them. The temperature. Increase in temperature means an increase in the rate of chemical reactions. We have seen that the temperature is a measure of motion of particles. An increase in temperature will cause the particles to move fast. When the particles move faster, more collisions occur, and more collisions are more energetic. Concentration. The more concentrated reactants, the faster the rate of reaction. An increase in the concentration means there are more particles. More particles means there will be more collisions. This should increase the reaction rate. Surface area. The larger the surface area, the faster the rate of reaction. When one of the reactants is a solid and the reaction can take place at the surface of the solid. Breaking the solid into smaller pieces will increase the surface area exposed to the other reactants. This should increase the reaction rates. Something like, example, like if you are trying to add sugar or salt to water. Let's say that if you are talking about sugar granules. So if you have a sugar granules big size, if you're trying to add it to the water, and if you have a very smoothly powdered sugar adding to the water, so we know that it is much easier for the sugar which is in the powder form to dissolve in the water easily than the sugar which is dissolved in the sugar cubes dissolved in the water. So I'm not saying that this is a reaction, but just like that, as you make the surface area more and more, the reaction rate would be higher and higher. Catalysts. Catalysts are substances that change the rate of the chemical reaction without being changed in the reaction. The catalysts are more often used to speed up a chemical reaction. So they will not really participate in the reaction, but they will make the reaction to happen faster. Or they will not react with any of the reactants. Catalysts affect the reaction by changing the steps needed between the reactants and the formation of the products. If the number of steps can be reduced, the reaction rate could increase. The reaction rates, the increase in temperature, higher concentration, increased surface area, these will increase the reaction rate. All have an influence on whether the constituent atom or molecule can become activated. The presence of a catalyst in a chemical reaction serves to alter the steps required in the chemical reaction. Chemical equilibrium. Chemical reactions are generally reversible. In most of the cases, equation is running back and forth in forward and reverse simultaneously. This back and forth process is in nature's way of finding equilibrium. Equilibrium is a state of balance determined by two opposing processes. As the two processes push the system toward the equilibrium, neither process will win, so they keep on going. So one will go in this direction, and once it is formed, then again it will start working backward. Rather, both processes will continue to occur with one balancing the effect of the other. The point of equilibrium can be altered by changing one of the two processes. Methods for altering equilibrium. Either we can change the concentration Either we can increase or decrease, change the temperature, either increase or decrease, change the pressure, either increase or decrease. So these are the things which would alter the equilibrium. Oxidation is not alone. There is another process related to the combination of oxygen with other substances, that is reduction. Oxidation is defined as the loss of electrons from an atom or an ion or combination of oxygen with other substances. Reduction is defined as gaining of an electron by an atom or an ion, also reducing the substance into its components. Oxidation and reduction occur simultaneously. If one particle gains electrons in a reaction, some other particle must lose them. So, if there is any reaction happening, that is like A and B are adding together to get a C, let's say. So, if A is losing the electron, then the B will be ready to take that electron. So, one will be losing and one will be gaining, and thus they will form a compound. So, this kind of reaction is called oxidation and reduction reaction. Reducing agent. The reactants that give up the electrons are called the reducing agent. The reducing agent contains the element that is oxidized. So you can see right here, the reducing agent, the reactant that gives up electron is called the reducing agent. And if a substance gives up electrons easily, it is said to be strong reducing agent. Oxidizing agent, the reactants that gains the electron is called oxidizing agent, and oxidizing agent contains the element that is reduced, which is gains electrons. If a substance gains electrons easily, it is said to be strong oxidizing agent. Understanding redox, which is oxidation state. The oxidation state of an atom is the charge an atom is presumed to have in one or more of its compounds or ions. Any reaction where electrons are transferred between reactants is called reduction, oxidation reaction, or redox reaction. One atom wants an electron so badly that it takes it away from any other atom. So, as I already explained, if you have two things trying to mix together, then one of them is looking for electron, the other one is trying to lose electron. So they combine together and make a redox reaction. One of the simplest types of redox reactions is a combination reaction. This reaction involves combining of two elements to form chemical compound. One element is always oxidized while the other is always reduced. One element replaces or displaces another to form a compound. In these reactions, known as single replacement reactions, the element which replaces that which is in compound is always oxidized. The element being displaced is always reduced. Some everyday examples: corrosion, which is forming rust, is a big problem. Oxide formed by oxidation does not firmly adhere to the surface of the metal and flakes off easily, causing pitting. Extensive pitting eventually causes the structural weakness and disintegration of the metal. Bleaching agents used to remove color from the substances such as textiles, papers. Most commercial bleaches are oxidizing agents such as sodium hypochlorite and hydrogen peroxide, which are quite effective in decolorizing the substances via oxidation. Decomposition reaction. A decomposition reaction is the opposite of a synthesis reaction. A complex molecule that breaks down into simpler ones. The reaction come in the general form of AB is going to break into A plus B. Electrolysis refers to the use of electric current to cause the separation of an ionic molecule. Electrolysis is an example of oxidation-reduction reaction. Some of the applications of electrolysis is electroplating, coating a metal object with a thin layer of another metal. It saves money by using only small amount of costly metals such as silver or gold. A thin layer can prevent oxidation of the metal structure. For example, silver plating. A solution of silver nitrate is dissolved into silver plus ions and nitrate ions. The positive, which is Ag plus ions, will drift towards the negative electrode, which is the subject or which is the object to be plated. So as you can see right here, so you have a spoon right here which we are trying to coat, and this is the silver nitrate solution. So this is the anode right here. So when the electricity is passed through that, the silver nitrate will decompose into Ag plus and NO3 minus. And since this is plus, it would be looking for one electron, so it would go to the negative electrode side, and it absorbs the electron and it becomes Ag, and it will be coated onto the silver right here. The silver ion gains an electron to become silver atom and becomes reduced here. Ag plus becomes reduced here, and thus the spoon is being silver plated. And you can see right here the silver atom loses an electron to become silver ion right here. Thus Ag is oxidized here. So here it is oxidized, and right here it will be reduced, and thus it becomes silver, and thus it will be coated onto the spoon. Electrochemical cell. This use of oxidation reduction reaction provides another way of harnessing the chemical energy. You may become familiar with the common name for the electrochemical cell, which is battery. The first electrochemical cell was invented by Volta, using two different metals separated by paths soaked in salt water. Since then, a variety of materials have been used to develop better batteries. In some electrochemical cells, the reactants get used up, while in other cell reactions can be reversed, recharging the battery. The lead-acid battery. These are the batteries in most automobiles. The battery consists of multiple cells, each of which contains electrodes made from lead and lead dioxide. The electrodes are surrounded by a solution of sulfuric acid. The sulfuric acid is dissociated into the constituent, which is H plus and SO4 minus ions, SO4 minus 2 ions. This is relatively new development in the energy providing devices, which is a fuel cell. The fuel cell is unlike an ordinary battery in that the chemical reaction is continuously fed, which means that the reaction can go indefinitely. The major drawback to this fuel cell technology is cost. It is a very cost ineffective to produce fuels. The chemical reaction summary is the combustion reaction is the rapid combination of oxygen with another substance. Heat, light are given off. Formula mass of the materials are found out. We found out what is a mole. The number of formula units in one of the mole is nothing but Avogadro number. And we talked about chemical reactions. And the chemical reactions is endothermic reactions absorb energy, exothermic release energy, and activation energy that is required to start the chemical reaction. Catalysts are the ones which will make the reaction go faster. Chemical equilibrium is reached when it is forward and reverse reactions do at the same time, same rate. Oxidation loss of electrons, reduction gain of electrons. Example is oxidation reduction reaction, electrolysis system, and batteries and fuel cells. This concludes the chapter 12.